Imagine this. You are in a dark room with a friend. You throw a ball at them to figure out where they are. The ball hits them and bounces back, telling you that they are there. Now that's pretty harmless in our everyday world. But in the quantum world, where particles are super tiny like electrons, even shining light on them to see them disturbs them. This is Heisenberg's uncertainty principle. Heisenberg's uncertainty principle says that you cannot know exactly both the position and the speed or momentum of a tiny particle like an electron at the same time. The more precisely you know one, the less precisely you can know the other. In simple words, if you know where a particle is, that is, if you know its position, you will have no idea how fast or in which direction it is going. And if you know exactly how fast it is going and in what direction it is going, you will never know where it exactly is. You will never know its position. But why does this happen? Because measuring something tiny changes it at the quantum level. Let's say you want to know where an electron is. So you shine a light on it. But light comes in photons, tiny particles of energy. When the photon hits the electron, it kicks it like a tiny billiard ball getting hit. Now the electron goes zooming off somewhere else. You saw where it was, but now you messed up its speed and direction. If you try to avoid disturbing it too much by using a lower energy photon, then you get a blurry image. You don't know where it is anymore. So, you can never have both the pieces of information, position and momentum, at the same time with perfect accuracy. What does this mean for reality? This is not just about measuring things badly, it is about how the universe actually works at the quantum level. Particles don't have fixed positions and speeds like billiard balls. They exist in a cloud of probabilities. Until you measure them, they are described by a wave function, a fuzzy idea of all the places where they might be. In a way, reality is what you observe. Let's understand this through an analogy. Imagine you are trying to photograph a hummingbird mid flight in a dark forest. You can either use a flash to freeze the position of the bird, but now you don't know how fast it was flying. Or alternatively, you can use a long exposure to track its motion, but then the position of the bird becomes blurry. Either way, you lose one detail to gain the other detail. That is the trade off in quantum mechanics. Heisenberg's principle does not mean that we don't know enough. It means nature will not allow us to know both the things at the same time. Reality, at its tiniest level, quantum level, is not made of precise little balls. It's wavy, uncertain, and beautifully weird. Thank you so much for listening.